February 2021, Texas. The temperature drops to -2 degrees Fahrenheit, the coldest North Texas has seen in over 70 years. Power plants freeze, natural gas pipelines seize up, and within 48 hours, more than 4.5 million homes go dark. No heat, no lights, no running water. Indoor temperatures fall below freezing. Families huddle under every blanket they own. Some run their cars in closed garages for warmth and die of carbon monoxide poisoning. Others burn furniture in fireplaces that haven't been used in decades. By the time the grid limps back to life, hundreds of people are dead. The official count says 246, though independent analyses suggest the real number may be closer to 700. In the aftermath, something strange starts trending online. Forum posts, TikTok videos, survival blogs, all making the same wild claim. You can heat a room with nothing but aluminum foil, table salt and water. Free heat, they say, can't be patented. And now, according to the posts, it's illegal in 23 states. Today on Historia Prime, we're going to pull that claim apart, piece by piece. Because the truth is more fascinating than any clickbait headline. The chemistry is real, the history is extraordinary, the economics are revealing, and the dangers are genuinely terrifying. But there's also a version of this story that ends with something you can actually use, tonight, safely, legally, to keep more heat inside your home. It starts with a metal that was once worth more than gold. The metal of kings. In the 1850s and 1860s, aluminium was the most glamorous substance on the planet. Not steel, not silver, aluminium. That sounds absurd today. You probably have a roll of it sitting next to your plastic wrap right now. But here's the thing. Aluminium is the most abundant metal in the Earth's crust. It's everywhere. The problem was that nature locked it away inside a mineral called bauxite, bonded so tightly to oxygen that no furnace, no acid, no known process could pry it loose cheaply. So when chemists finally managed to isolate small quantities of pure aluminium, the world treated it like a miracle material. France displayed aluminium bars alongside the crown jewels at the 1855 Exposition Universelle. The story goes that Emperor Napoleon III reserved his prized aluminium cutlery for his most honored dinner guests, while everyone else had to settle for gold. Whether that story is perfectly accurate or slightly embellished, the underlying fact is documented. Aluminium was genuinely more expensive than gold for much of the 19th century. And then two 22-year-olds changed everything. In 1886, working independently on opposite sides of the Atlantic, American Charles Martin Hall and Frenchman Paul Héroult each discovered that you could dissolve aluminium ore in a bath of molten cryolite and blast it with massive amounts of electricity. Pure aluminium would collect at the bottom of the tank. The Hall-Héroult process, as it's still called today, cracked the code. Prices that had been hundreds of dollars per pound collapsed to about 50 cents within a decade. The most coveted metal in the world became the stuff of soda cans and baking sheets. By the early 20th century, aluminium foil was being rolled to 1/1000th of an inch thick and sold in grocery stores. The metal of kings had become a throwaway commodity. But here is the part that almost nobody talks about, and it's the key to this entire story. When those industrial smelters pump roughly 15 kilowatt-hours of electricity into every single kilogram of aluminium, that energy doesn't just vanish. It gets stored inside the metal's atomic structure. In its refined state, aluminium is essentially a very dense energy battery. Gram for gram, it holds several times more energy than the lithium-ion cell in your phone. Every sheet of foil you've ever crumpled up and thrown away was packed with trapped energy. So why doesn't it burst into flames the moment it touches water in your kitchen sink? The invisible armor. The answer is one of nature's most elegant defense mechanisms. The instant a fresh sheet of aluminium leaves the rolling mill and touches air, It reacts with oxygen. Within microseconds, it forms a skin of aluminium oxide. This layer is almost unimaginably thin, roughly 3 to 5 nanometers, which is about 15 atoms deep. Thousands of times thinner than a human hair, and yet this microscopic coating is extraordinarily tough. It seals the reactive metal underneath completely, blocking water, air, and most chemicals from reaching it. This is the reason aluminium foil can wrap acidic lemons, sit in humid drawers for years, and line baking pans at 400 degrees without corroding. The real trick is that the oxide layer is self-healing. Scratch it, and a new layer forms before you can blink. The enormous energy that cost a fortune in electricity to produce stays locked away, inert, as long as that invisible armor holds. For most of human history, that was the end of the story. The energy was trapped, and it stayed trapped. But then someone found a key. The chemistry in your pantry. This is where the viral free heat claim originates, and the underlying science is genuinely fascinating. When you dissolve ordinary table salt, sodium chloride, in water and introduce crumpled aluminum foil, you unleash something chemists call chloride-induced pitting corrosion. The chloride ions in the salt solution are aggressive. They attack the microscopic defects in the aluminium oxide layer, worming their way through the armor until they reach the raw metal beneath. The moment bare aluminum meets water, the reaction is immediate and violent. The aluminum rips oxygen straight out of the water molecules. Hydrogen gas bubbles furiously from the surface, and the liquid heats up, measurably, noticeably. The thermodynamics confirm it. A single gram of aluminum reacting with water releases about 30 kilojoules of energy. Roughly half of that emerges as heat. In a controlled demonstration, a small piece of foil in salted water can push the temperature up by several degrees in under a minute. So the reaction is real. The heat is real. The bubbling you see in those viral videos is real hydrogen gas being produced right before your eyes. But here's the question that separates science from fantasy. Is it free? And is it forever? The answer to both is no. Thermodynamics has a rule that never bends. You cannot get more energy out of a system than was put into it. The aluminum is consumed during the reaction. It transforms into a chalky sludge, aluminum hydroxide, and once it's gone, the heat stops. You're not creating energy from nothing. You're releasing a fraction of the energy that a massive industrial smelter poured into the metal months or years ago. And the economics are brutal. It takes about 15 kilowatt-hours of electricity to produce a kilogram of foil, but you only recover roughly 30% of that energy when you react it with water. The rest was lost as heat during the smelting process itself. Financially, heating your home by dissolving aluminium foil would cost many times more per unit of heat than simply burning natural gas or running an electric heater. So, free heat forever is a half-truth. The chemistry works, the math doesn't. But the allure of the idea that you could bypass the entire energy industry with items from your kitchen is powerful enough that millions of people shared those videos without ever checking the numbers. The patent question. The next part of the viral narrative goes like this. Big energy companies are terrified of this reaction because they can't patent it. There's a kernel of truth here. You cannot patent a naturally occurring chemical reaction. The interaction between aluminium, salt, and water is basic chemistry. It's been documented in corrosion science textbooks for decades. It's public domain knowledge, and no corporation can lock it up. But that's very different from saying the technology is being suppressed. The real story is more interesting. Serious researchers and engineers have been working for years to harness aluminium-water reactions in practical, controlled ways. One of the most notable efforts came from Purdue University, where a research team discovered that coating aluminium with liquid gallium, a rare metal that stays liquid near room temperature, could continuously dissolve the oxide layer, creating a reliable, on-demand source of hydrogen and heat. That discovery was patented. Not the reaction itself, but the specific engineering that makes it practical and safe. And Purdue isn't alone. Multiple companies and research institutions are actively developing aluminium-based energy systems for off-grid and mobile applications. So nobody is suppressing this science. The real reason it hasn't replaced your furnace is much simpler than a conspiracy. The economics don't work for home heating. You can't build a recurring revenue business around a reaction that uses a consumable metal less efficiently than existing fuels. No company will spend millions marketing a product that costs the consumer more per unit of heat than what they're already using. When a technology can't be patented into a profitable product, it doesn't get suppressed. It just doesn't get a marketing budget. That distinction matters, because the internet loves a David versus Goliath story, and the idea of a hidden back door to free energy is one of the most psychologically compelling narratives ever invented. It feels like autonomy. It feels like outsmarting the system. But sometimes, outsmarting the system means playing with forces that can kill you. The reason people get hurt. Let's talk about what actually happens when someone builds one of these devices at home. Remember the bubbling in those videos? That's hydrogen gas. And hydrogen is one of the most dangerous gases you can produce in an enclosed space. Hydrogen is explosive at concentrations between 4 and 74% in air. That's an extraordinarily wide, flammable range compared to most gases. But what makes it truly terrifying is how little energy it takes to ignite. About 0.03 of a millijoule. For perspective, the static spark you generate pulling a wool sweater over your head is several times more powerful than that. Now picture this. A homeowner, trying to save money during a cold snap, sets up a plastic bottle with salt water and crumpled foil. The reaction starts bubbling. Heat rises. But invisible hydrogen gas is also rising, pooling against the ceiling. Someone flips a light switch. A tiny electrical arc jumps across the contacts, and the room detonates. This isn't hypothetical. Fire departments have responded to incidents involving improvised chemical heating devices. And the danger escalates dramatically when people follow online advice to swap table salt for sodium hydroxide, commonly known as lye, the active ingredient in many drain cleaners. Lye accelerates the reaction enormously, producing far more heat and hydrogen far faster. But lye is also one of the most destructive substances you can encounter in a household setting. It doesn't just burn skin the way an acid does. It saponifies tissue, meaning it chemically converts the fats and proteins in human skin into something resembling soap, dissolving flesh slowly and deeply. When an unvented, overpressurized plastic container inevitably ruptures from the heat and gas buildup, it can spray boiling caustic sludge across a room. This is why building codes and fire codes exist. Under regulations like the National Fire Protection Association standards and the International Fire Code, constructing an unregulated, unvented hydrogen-generating device in a residential zone is a serious violation. The legal issue isn't that you're generating free energy. The issue is that you're building what amounts to an uncontrolled pressure vessel filled with explosive gas in a space where other people live. The viral claim that this is illegal in 23 states is misleading in its framing. There isn't a specific law targeting salt and foil reactions. What exists are broadly applicable fire safety codes that prohibit unregulated hydrogen generation in residential settings. The same codes that would apply to any improvised chemical device. The framing makes it sound like a targeted conspiracy. The reality is standard building safety regulation. A safety note here because it matters. If you or anyone you know has been exposed to lye or any caustic chemical, flush the affected area with clean water for at least 20 minutes and call emergency services immediately. This is not the kind of burn you can treat at home. The heat hack that actually works. So here's the twist in this story. There is a way to use aluminium foil to meaningfully reduce your heating bill. It's completely safe. It's completely legal. Energy researchers have studied it, and you can do it tonight with materials you probably already own. It has nothing to do with chemical reactions. It's pure physics. If you have wall-mounted radiators, especially on exterior walls in older buildings constructed before modern insulation standards, a significant portion of your heating energy is being wasted. Radiators don't just heat the air in front of them. They radiate infrared energy in all directions, including straight backward into the wall. That wall absorbs the heat and conducts it outside. You're literally paying to warm the bricks. The fix is almost comically simple. Take a piece of rigid cardboard from a delivery box, a piece of foam board, anything flat and sturdy. Wrap one side tightly in aluminium foil, shiny side facing out. Slide it behind your radiator, reflective side facing the room, with a small air gap between the panel and the wall. The foil acts as a mirror for infrared radiation. Instead of your wall absorbing that heat, the panel bounces it back into the room. The radiator doesn't work any harder. The boiler doesn't burn any more fuel. You're simply redirecting energy you were already paying for. Research published in the journal Applied Energy found that installing reflective foil behind radiators reduced heat loss through the wall behind the radiator to less than 30% of its original value. In terms of total room energy consumption, savings of around 5 to 6% were recorded in controlled tests, and in poorly insulated buildings, that number can climb higher. A study at the University of Salford's Energy House Laboratory, which simulates real UK winter conditions, confirmed measurable reductions in heating gas consumption. 5 or 6% might not sound dramatic, but across an entire heating season, across every radiator in your home, it adds up to real money. For the cost of a cardboard box and a roll of foil. A few practical tips if you want to try this. The air gap matters. Even 1 or 2 centimeters between the reflective panel and the wall makes a meaningful difference because it allows the foil to reflect rather than conduct. The technique works best on uninsulated exterior walls. On interior walls or well-insulated modern construction, the benefit drops to near zero because there's less heat escaping in the first place. And don't block the top or front of the radiator. You want hot air to rise freely and circulate. No explosions, no hydrogen gas, no caustic chemicals. Just the quiet, brilliant physics of reflection, turning wasted energy back into warmth you can feel. Conclusion. The story of aluminium and salt is really a story about us. We took a metal that emperors displayed alongside crown jewels and made it so cheap we throw it away without thinking. We forgot that every crumpled sheet carries an enormous amount of stored energy, a legacy of the industrial electricity that forged it. And when the internet promised us a way to unlock that energy for free, millions of people wanted to believe it, because the idea of self-reliance in a crisis is one of the most powerful human impulses there is. The chemistry behind the viral claim is genuine. The energy inside aluminium foil is real and measurable. But the practical reality of harnessing it at home is economically wasteful and physically dangerous. True survival knowledge has never been about chasing shortcuts. It's about understanding the actual science well enough to know which tools to reach for and which ones to leave alone. Think back to that freezing week in Texas. 4.5 million homes without power. Hundreds of people dead. In that kind of crisis, the instinct to try anything, to grab whatever is in the kitchen and make heat happen, is completely understandable. But the people who survive emergencies aren't the ones who follow the most dramatic advice. They're the ones who prepared before the crisis hit, with knowledge grounded in physics, not panic. Tonight, you could slide a piece of foil-wrapped cardboard behind your radiator and start saving energy immediately. No risk, no special tools, just a quiet act of physics that works every single day, all winter long. That's the real secret of the silver sheet. Not a chemical explosion in a bottle, just light bouncing back to where it belongs. If you found this deep dive into lost history and hidden science valuable, hit that like button and subscribe to Historia Prime. Share this video with someone who needs to hear it. And as always, respect the elements, stay curious, and keep exploring the past to prepare for the future.